Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use the concept of quotient rule to solve this problem. So let's start with the first problem. So show that there are no tangents to the graph of f at x equals f5x plus 2 over x plus 2 that have a negative slope. So in this problem, we have to prove that all tangents to the graph of this function have either 0 or positive slope. So none of them will have a negative slope. Now since we have to analyze the slope of the tangent to this graph, so the first step is to find the derivative of this function because that will represent the slope of the tangent. Now this is a rational function, so we can use quotient rule to find the derivative of this function. So the first step is, so m, the slope of the tangent, is equal to the prime of f of x, which will be equal to, so as per the quotient rule, we'll start with the derivative of the numerator, which is 5 times the denominator x plus 2, then minus the numerator, which is 5x plus 2 times the derivative of the denominator, which will be 1. Because 2 is a constant, so derivative of 2 is 0, so 0 won't matter, over the square of the denominator. Now we can simplify this expression. So in the numerator, we can distribute the 5 into the parentheses. So we get 5x plus 10. And now in the other part of the numerator, we can distribute the negative sign into the parentheses, and that will change the sign of all terms in the parentheses. Over the multiplication by 1 won't change anything, so that's why we get negative 5x minus 2. And the denominator will stay the same. Now we can like terms in the numerator. So 5x and negative 5x will cancel each other out, and 10 minus 2 can be reduced to 8 over x plus 2 squared. Now if we analyze this expression, so for all x values, this expression will have a positive value because the numerator is 8, so that won't be affected by the x value whether it's positive or negative, and the denominator is a perfect square, so that's why for every x value, positive or negative, the denominator will be a positive number. So that means this expression will always have a positive value for all x values. So therefore, no tangent to the graph of this function will have a negative slope. So here we do not have to find the values of the slope of the tangent. We just have to prove analytically that this expression cannot have a negative value. So this is how we solve this type of problem. Now we can work on the second problem. So as per the second problem, determine the equation of the tangent to the curve y equals x squared minus 1 over 3x at x equals 2. So in this problem, we have to find the equation of the tangent. And we know tangent is a straight line. So the general equation of a straight line is y equals mx plus b in slope-intercept form. Now in order to write the equation of the tangent, we need to know its slope and y-intercept. So the first step is to find the derivative of this given function to get the slope of the tangent at x equals 2. So since this is a rational function, we can use the quotient rule. So the first step is m equals, which is equal to the derivative of this y function, which will be y prime. And now we can use the quotient rule. So we start with the derivative of the numerator, which will 2x, because 1 is a constant, so its derivative will be 0, times the denominator minus the numerator expression x squared minus 1 times the derivative of the denominator, which is just 3 over the square of the denominator. Now we have to find the equation of the tangent at x equals 2. So we can sub in x equals 2 in this expression to find the slope of the tangent at that point. So we get m equals, in the numerator, we get times 2 and then 3 times minus, so in parentheses 2 squared minus 1 times 3 over 3 times 2 squared. Now we can simplify this expression. So 2 times 2 is 4, 4 times 3 is 12, and 12 times 2 is 24. So we get 24 minus, so in the parentheses we do 2 square, which is 4, 4 minus 1 is 3. We get 3 times 3. And in the denominator we do 3 times 2, which is 6, so we get 6 squared. Now we can simplify it further. So we get 24 minus 9 over 36. Now we can subtract 9 from 24. So we get m equals 15 over 36, which can be reduced to 5 over 12. So this should be the final answer for the slope of the tangent at x equals 2. Now we will sub in this m value in our equation for the tangent line. So we get y equals 5 over 12 x plus b. Now in order to find the b value, the y-intercept, we need a point that lies on this tangent line. Now we have to find the tangent at y equals x squared minus 1 over 3x at x equals 2. So x equal 2 represents the point at which the tangent touches the curve. So if we use this equation of the curve to find the y value, so we will know the point that lies on the tangent, because that point lies both on the tangent and the curve. So we should sub in x as 2 in the equation of the curve. So we get 2 squared minus 1 over 3 times 2, which can be simplified to 4 minus 1 over 6, which is equal to 3 over 6, and this can be reduced to 1 over 2. So one point that lies on the tangent line is 2, 1 over 2. Now we can sub in this point in the equation of the tangent line to find the value of b. So x is 2 and y is 1 over 2. So the equation of the tangent line becomes 1 over 2 equals 5 over 12 times 2 plus b. Now we can simplify the step. So we get 1 over 2 plus 10 over 12, which can be reduced to 5 over 6. So we get 1 over 2 equals 5 over 6 plus b. Now we can isolate b by subtracting 5 over 6 from both sides. So the 5 over 6 on the right side cancel each other out, and on the left side we'll have to do 1 over 2 minus 5 over 6 equals b. Now we can subtract these fractions by finding a common denominator, which is 6. So we'll multiply the first fraction by 3 in the numerator and the denominator. So we get 3 over 6 minus 5 over 6 equals b. And now we can subtract these fractions. So 3 minus 5 is negative 2. So negative 2 over 6 equals 3. And this can be reduced to just negative 1 over 3. So this is the y-intercept of the tangent line. And now we can write the equation of the tangent. So I'll write it here on the left side. So the equation of the tangent will be y equals 5 over 12 x minus 1 over 3. So this should be the final answer for the equation of the tangent line. So these are the steps you have to keep in mind to solve problems like these. So in both of these problems, we had to find the slope of the tangent line from the derivative of the given function. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.